The Moon has fascinated us for millennia, influencing cultures, calendars, and even our oceans. Let us explore various aspects of the Moon, including its properties, surface, composition, and its synchronous rotation. The Moon, Earth's only natural satellite, is about 1/4 the size of Earth with a diameter of 3,474 kilometers. Despite its smaller size, the Moon significantly impacts Earth, especially evident in ocean tides caused by its gravitational pull. It has a mass of 7.35 by 10 to the 22 kilograms, roughly 1/81st of Earth's mass. And its gravity is about 1/6 that of Earth, allowing astronauts to hop and float on its surface. The Moon orbits Earth at an average distance of 384,400 kilometers, completing one orbit in approximately 27.3 days. This orbital period is synchronized with its rotational period, meaning the same side of the Moon always faces Earth. This phenomenon, known as synchronous rotation, results in the near side and far side of the Moon, with the latter often mistakenly referred to as the dark side, though it experiences similar phases of illumination as the near side. The Moon lacks an atmosphere, leading to extreme temperature variations between day and night, ranging from about 127 degrees Celsius during the day to -173 degrees Celsius at night. The absence of an atmosphere also means no weathering or erosion occurs, preserving surface features for millions of years. Its surface is marked by craters, mountains, valleys, and flat plains, reflecting its tumultuous history of impacts and volcanic activity. Despite its barren appearance, the Moon has water ice and permanently shadowed craters near its poles, discovered by recent missions. The Moon's surface reflects sunlight, which contributes to its brightness in the night sky. It has phases results from the changing positions of the Sun, Earth, and Moon. Understanding the Moon's properties and characteristics provides insight into its influence on Earth, and its role in the broader context of the solar system. The lunar surface is a fascinating and diverse landscape, offering a window into the history of our solar system. The surface is predominantly covered with regolith, a layer of loose, fragmented material, resulting from countless impacts over the years. This regolith varies in thickness, being deeper in the lunar highlands, and shallower in the Mare. The Mare, or Mare, Latin for seas, are large, dark, smooth plains of basaltic rock, created by ancient volcanic eruptions. Despite their name, these areas are not bodies of water, but vast solidified lava flows. The Mare are primarily located on the near side of the Moon, covering about 16% of its surface. Their smooth, relatively flat appearance contrasts with the rugged terrain of the Highlands. Examples include Mare Imbrium, and Mare Tranquillitatis, where Apollo 11 landed in 1969. The lunar highlands are older, more heavily cratered regions, composed mainly of anorthosite, a type of rock rich in feldspar. These are lunar regions that are light in color, and mountainous. These highlands are more reflective than the Mare, and represent some of the oldest surfaces on the Moon, dating back over 4 billion years. The contrast between the highlands and the Mare highlights the Moon's geological history, marked by intense periods of volcanism and impact cratering. Craters dominate the Moon's surface, depression formed by the impact of meteoroids, comets, and asteroids. These craters range in size, from tiny pits to massive basins. Some notable craters include Tycho, with its prominent rays visible from Earth, and the large South Pole Aitken Basin, one of the largest known impact craters in the Solar System. These craters offer insights into the frequency and scale of impact events in the early Solar System. Lunar ejecta includes debris ejected during the formation of an impact crater. When an object massive enough hits another object with enough force, it creates a shock wave that spreads out from the impact. The object breaks and excavates into the ground and rock, at the same time spraying material known as impact ejecta. This ejecta is distributed outward from the crater's rim onto the surface as debris. It can be loose material, or a blanket of debris, which thins at the outermost regions. Additionally, the Moon's surface features include rilles, which are meandering channel-like structures, thought to be the result of ancient lava flows, or tectonic activity. This can be described as long and narrow depressions, or valley-like structures, on the Moon's surface, and appears to have been formed by subsidence, or collapse of surface. And Grabens, which are broad sunken blocks of crust, bounded by fault lines. They are formed when the crust is stretched, breaks, and drops down, along two bounding faults, creating a trough or valley. Typically straight, or slightly curved, wider and more trench-like, with a significant drop in elevation, between parallel faults. The Moon's rotation is a fascinating aspect of its dynamics and relationship with Earth. It takes the Moon approximately 27.3 days to complete one rotation on its axis, which is the same amount of time it takes to orbit Earth, or 27 days. This synchronous rotation results in the same side of the Moon always facing Earth, a phenomenon known as tidal locking. This occurs because of the gravitational interactions between Earth and the Moon. This means we always see the near side of the Moon, while the far side remains hidden from view. Let us observe the synchronous rotation of the Moon. On the left, it shows the Moon rotating at the same rate that it revolves around Earth, so the same hemisphere faces Earth all the time. The results of the synchronous rotation can be seen on the right. It shows the Moon does not seem to be spinning, but appears to observers from Earth to be keeping almost perfectly still.